Hello students, this is Sadat Sheikh and I would be taking an introduction to a very important topic in our physics syllabus for 11th standard as well as NEET and JEE. The topic for today would be relative motion. A very interesting topic and a topic which is very practical in our day-to-day life. Relative motion, as the word suggests, there will be two objects, either both of them will be in motion or any one of them will be in motion, and we need to find out what is the relative velocity between them, or we need to find out what is the relative displacement between them. We can also find out the time of crossing, etc. Overall, what I would like to suggest is that this topic is very important for every NEET and JEE aspirant, and this is based on our kinematics equation as well. So you need to have a background of kinematic equations. Since I am giving a brief introduction about this topic, let's begin. For example, there are two objects. Let us take a train, and this train is moving in a certain direction, and let us assume that velocity of this train A is 60 km per hour, and the person inside this train or the passenger sitting inside this train will feel as if the trees are moving with a certain velocity passing by. The trees which are passing by this train, they will be having a certain velocity. The person inside this train will feel as if the tree is having a certain velocity, but the reality is the tree is at rest. Velocity of tree is actually zero. So why would a passenger sitting inside this train will feel as if the trees are in motion? Because this object is in motion, and if anyone is in motion, he feels as if the other object is also in motion. Hence we need to find out the relative velocity of the other object with respect to us, or the relative velocity of us with respect to any other object. And the basic formula they have given to find out any relative velocity is nothing but velocity of A with respect to B is nothing but VA bar minus VB bar. For example, let us consider the situation. There is a train having a certain velocity in a certain direction. There is a velocity of this tree also. I have mentioned that the tree is at rest. If in the examination they ask what is the velocity of train A with respect to tree, or they can also ask what is the velocity of this tree with respect to train. Hence we can substitute our values and we can easily find out the relative velocity, like velocity of tree with respect to train A will be Vt bar minus Va bar. What is Vt bar actually? 0. It is 0. We can write this as 0 minus, what is Va bar in this scenario? 60. Maybe this train is in motion along I cap, or it may be along minus I cap. We can also write it in vector form. 0 minus 60 I cap, our answer will be minus 60 I cap. This minus 60 I cap is actually the relative velocity of this object with respect to train. Velocity of tree with respect to train A is nothing but minus 60 I cap, or I can say in a layman's language that the passenger sitting inside this train will feel as if the trees are moving with a velocity of 60 I cap in opposite direction, in minus I cap direction. Now let us consider two objects and both of them are in motion. For example, there is a train, and let us assume that the train A is moving with a velocity of 60 km per hour, again in a particular direction. Let us assume that it is in I cap. There is another train which is moving in the same direction, but that train is having a velocity, let us say 40 km per hour. Now, the passenger sitting inside train A will feel as if the train B is moving backwards with a certain velocity. Likewise, the passenger sitting inside train B will feel as if the train A is moving in positive x-axis with a certain velocity. But what is that velocity called as? And that velocity is called as relative velocity. And since we have already understood what is the formula, now we can directly substitute what is the relative velocity of train A with respect to train B, or else what is the relative velocity of train B with respect to train A. Maybe the passenger inside train B will feel train A is moving with a certain velocity in a certain direction, else the passenger sitting inside train A will feel as if train B is moving in a certain direction. We can find out both the magnitudes as well as direction. How? The formula is VA bar minus VB bar. Similarly, in this case, the formula is VB bar minus VA bar. Let us substitute the values. What is VA bar in this case? VA bar is 60 I cap. What is VB bar in this case? It is 40 I cap. What is 60 minus 40? We will get 20 I cap. Hence, the passenger sitting inside train B will feel as if train A is moving with a speed of 20 km per hour in positive x-axis or in I cap. Similarly, we can also find out what the passengers sitting inside train A will feel. Let us substitute the values. What is VB bar? 40 I cap. What is VA bar? 60 I cap. And by substituting the values, 40 minus 60 is minus 20 I cap. So this suggests what? This suggests that the passengers sitting inside train A will feel as if the train B is moving with a speed of 20 km per hour but in opposite direction. This minus sign indicates opposite